binomial distribution can be applied for a finite number of data. When the number of data is very large, we can go for the Poisson distribution because it will give us a more valid result than the binomial. The same problem can be solved both by binomial as well as Poisson. Okay, but according to the number of trials, what you are going to do, you decide which will be a better one. So number of trials are less means you can go for binomial. Number of trials are large means you can go for the Poisson distribution. So how we define the Poisson distribution? Yes. Equal minus lambda power x by x factorial. What is the range of x value? 0, 1, etc. up to infinity. Okay, but that is the value for x range. Which is called as a parameter? Lambda will be called as the parameter. For binomial, how many parameters are there? 2 parameters. What are they? N and P. Okay, what are the parameters for binomial? N and P. Okay, wow. Now we can connect the binomial distribution and the Poisson distribution to a limiting distribution. That is by imposing some conditions. So here, I might be absent. Hostel student, why you are late? Why you are late, hostel student? We can derive the corresponding Poisson distributions. Okay. So one of the condition back, what we can implement is that we can assume lambda is equal to np. Okay. So what is the assumption? Lambda equal to np. Remember this one. In some cases, to solve the problems, we need this relation. Okay. You may not be given what is the lambda value directly. Instead of that, you may be given n and p value. So using n and p value, you can find what is here lambda. So what is the relation? Lambda is equal to np. Make a note of this one. Lambda is equal to np. Lambda is equal to np. Okay, Amma? So as usual, what is the next thing we are going to do is that we are going to find what is the MGF, what is the mean, and what is the variance. By which procedure you will get that one? Direct formula or using MGF? Using MGF. Try to practice it that way, that will be the easiest one for you. What is the formula for MGF? MGF ma? Mx of t equal to Q plus P. Are we in binomial distribution or Poisson distribution? Poisson. We are going to derive what is the MGF. I am asking you what is the MGF formula?
E of e power t.
Expectation of e power tx. I am not asking the mean formula. What I have written is MGF. What is MGF formula? Expectation of e power tx. This is discrete case or continuous case? Discrete. So what is the formula for discrete? Forgotten everything. Summation of e power tx into probability of x equal to x. That is the formula. This is the general formula of MGF which we discussed in our unit 1. Now itself is forgotten. What you will do for your CF 1? What? The same silence will be the marks in your paper, right? Yes or no? But my simple formulas every day repeatedly telling you, remember at least the formulas. So what is the MGF formula? Summation of e power tx into p of x. Now we are going to solve it for the Poisson. So replace this by the Poisson definition. So this is equal to summation e power tx e power minus lambda power x by x factorial. Substitute in the definition of Poisson. What is the range of x value? 0 to infinity. So x varies from 0 to infinity. So now we have to expand this one and define what is your MGF. Okay. So the summation depends on the x value. Whether there is any term which is independent of x. We are going to expand the summation based on x value, right? If there is any term which is independent of x, x illada term edadukka? E power minus 1. This does not contain any x terms. So you can take it outside as summation. can we combine any two terms together, ma?
E power dx.
E power dx and lambda power x, because both are powers of x. So both can be combined and written as lambda e power t the whole power x by x factorial. Since both is powers of x, we can combine and write it as one single term. Now expand it and identify what will be the corresponding formula. So to the expansion, e power minus lambda into first one x equal to 0. Robert, what is the answer? You are only Robert, right? Then what is the answer? X equal to 0. I know that you are waiting for the person to call you for sports, at least for the remaining time you have to listen. No? What you are doing in exams, always going outside. What will happen if you substitute x equal to 0? Simple, must see the board and tell me the answer. Wherever x is there, replace it as 0. What will happen? I am asking you to respond to me or not. What is the answer? Where is this fix? Show that term. Show that term please. Where is your notebook? You are not written. You are making me to waste the time on. Say it fast. The next person remain in silence mode. Don't help him. Just show him only the question. Others continue. So what happened when x is equal to 0?
Lambda e power.
Lambda e power t the whole power 0. Anything to the power of 0 is 1. Anything to the power of 0 is 1. Denominator 0 factorial. What is 0 factorial? 0 factorial is 1. Okay, 0 factorial is equal to 1. Shall get the first term to be 1. Now substitute x is equal to 1. X equal to 1, lambda e power t by 1 factorial plus x equal to 2. Lambda e power t the whole square by 2 factorial. Lambda equal to 3.
Lambda e power t the whole cube by 3 factorial.
So etc. it goes up to infinity, right? So this represents which expansion formula? Already on that day I discussed with you the formula. Do you remember? This represents which formula? Instead of lambda e power t, assume it as x. So what is the expansion you will get? 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, etc. Okay, wow. It represents which formula? Sit down. Turn the pages. How many pages you are going to turn? On that day I gave you the binomial formula. But I told you about another formula also. What is that one? This does not belong to binomial.
X power n.
This does not belong to binomial. Binomial expansion will not have the denominator terms. Here the denominators contain factorial terms. What Poisson formula? Okay, tell me the expression. The experiment. It belongs to exponential formula e power x. Do you remember on that day I told you there are two formulas also. What is e power x? What is e power minus x? So this belongs to the exponential formula. At least now we know down the expansion. Yes. E power x is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus etc. This is your e power x formula. E power minus x means alternatively it will be plus and minus. Okay. Now replace it here. What will happen? Instead of x we are having lambda e power t. So we will get it as e power minus lambda e power lambda e power t. You understand now? E power x formula. Instead of x we are having the term as lambda e power t. So since the base is same, both is having the same base, we can add the power. So if you add the power, you can write this one as e power lambda into e power t minus 1. Because lambda is common in both, you can take it outside. So this will become e power t and this will become minus 1. Okay, so this is the MGF for our Poisson distribution. E power lambda into e power t minus 1, everything in the power. Lambda into e power t minus 1 is in the power form. Can you understand? Just 3 lines derivation. So if you are lucky, all these things can be asked as 16 mark. Derive them MGF, mean and variance of any distribution. Okay, problem. Still you are not practiced with parallel copying. Yes. So what is MGF?
E power lambda.
E power lambda into
E power t
e power t
minus 1.
minus 1. Now using this MGF, what you are going to do? You are going to derive what is the mean and what is the variance. So write mean is equal to you all know the formula for mean? Using MGF, what is the formula? Using MGF, d by dt of mx of t at t equal to 0. The different notations of mean will be, it will be same as e of x, or it is equal to x bar, or it is equal to mu. Everything indicates the mean value. Either e of x, x bar or mu. Now substitute the MGF and differentiate d by dt of e power lambda into e power t minus 1 with the condition t equal to 0. So if you differentiate the exponential, what is differential of e power x? E power x itself. Instead of x, you are having this 2. So first you are differentiating exponential. So e power lambda into e power t minus 1 as it is. Now we have done the differentiation only for the exponential. Now we have to do the differentiation for the power. So we are going to differentiate with respect to t. So lambda is your constant in multiplication, it will remain the same. Now differentiate the inner term. What is differential of e power t? E power t. What is differential of 1? 0. So lambda into e power t with the condition t equal to 0. Now wherever t is there, replace it as 0. So e power 0 will become 1. What is 1 minus 1? 0. Lambda into 0? 0. E power 0? 1. Lambda into, again e power 0? 1. So what will be your final answer? Lambda. So what is the mean of Poisson distribution? Lambda. Okay. Now we have to find variance now. To find variance, what are you supposed to find? What is that one? E of x squared. To find variance, we need what is e of x squared. So start finding that one. E of x squared is equal to d square by dt square of mx of t at t equal to 0. Okay, we have to differentiate the MGF once. Already we differentiated once in your mean. So take that answer directly. So this is equal to d by dt of, the first differentiation answer is e power lambda into e power t minus 1 lambda into e power t. Okay, already we have differentiated, take that answer directly, no need to differentiate it again. Now we have to differentiate this with respect to t. How will you do it? Direct differentiation is possible? UV, because two terms is having t variable. This exponential is also having the t term, this is also having a t term. So there are two terms with t variables. So you have to make use of your product too. So whether lambda is a constant or a variable, constant, it does not have the t term. So it can be taken outside the differentiation. So this is equal to lambda into product 2. So keep the first term as it is. E power lambda into e power t minus 1. Differentiate e power t, a power t. Plus, now keep this e power t as it is. Differentiate this term as we did for our first differentiation. So what is differential of e power x? E power x. E power lambda into e power t minus 1. We have differentiate only for the exponential. Now we have differentiate again for the power 2. So lambda will remain as it is. What is differential of e power t? A power. So everything within the condition t equal to 0. Same way of differentiation. Now everywhere it is t equal to 0, what will happen? First term. E power 0. What is equal to 0? 1. 1 minus 1. 0. E power 0? 1. Again here? E power 0? 1. So first term will be as 1. Again e power 0? This one? 1. And this one? What will happen to this one? Lambda. So it will get simply as 1 plus lambda. If you multiply lambda inside, lambda plus lambda square. So this is our e of x square. Copy on. Which one? E power t. 1 into anything is? Here into only. No, ma. Here it is into only. No, this term into this term. Those are completed proceed with the variance. Now how to find the variance? You know the formula. Substitute the formula and find what is the variance. Variance is it 1 plus lambda not? Check it. Lambda. Shall I proceed with variance? Everyone? So what is the variance formula? E of x equal to E of x square minus E of x the whole square. So what is the E of x square answer? Lambda plus lambda square minus. What is E of x? Lambda. So it is lambda square. So what will happen? We will get it to be lambda. So for Poisson distribution, mean and variance are same. Both are equal to lambda. So lambda is a parameter as well as it is the same mean as well as the variance for Poisson distribution. All the three are the same values. So assertion, memorize everything first thoroughly, then only solving the problems. First you should know all the basic formulas. So where the formula is for unit 1 is ready? Boys, yeah, should prepare a formula list for unit 1. Is it ready? Should I check it? Girls, everyone is ready, ma'am? Boys, actually 2 weeks before I gave that work, right? Before you see that one. Boys, are you ready with the formula list? Everyone? Can I check? Very good. Okay, should I proceed, ma'am? Any doubt? Should I recall how we define the Poisson distribution? E power minus lambda, lambda power x by x factorial. X varies from 0 to a to b. What is the mean? Lambda. What is the variance? Lambda. What is the HCF? E power t. What is the HCF of Poisson distribution? E power lambda into e power t minus 1. Be careful, memorize all these things thoroughly. Okay, ma'am. Then which is called as a parameter for Poisson distribution? Lambda. Okay. So now as usual we discuss the problems in the binomial. We are going to discuss the problems in Poisson distribution. Okay. So take down. When you read the statement itself, you will understand the difference binomial and Poisson. In binomial distribution normally we discuss with the childhood problems. Okay, I will discuss with the coin problem or a dice problem, which is for everything the number of exhaustion is a finite. Okay, child birth means what is the possibilities? It is boy or girl. That's all two possibilities. 4 up. 2, right? Okay. Then for dice, throwing a dice, 6. Tossing a coin, 2. Like that one, it was like a standard one. But when it comes to the Poisson, the problems will not be like that one. It will be like a generalized problems. Okay. So take your first one. First one. At a busy traffic junction. At a busy traffic junction, comma, the probability of an individual having an accident is P equal to 0.0001. P equal to 0.001. However, during a certain part of the day, comma, 1,000 cars pass through the junction. 1,000 cars pass through the junction. Who's paying? Where is it? यहाँ पे धारा बदली हुई है, कुछ नहीं लिखे होगा तो take your pen. Now anyone is having any other pen? 2 pens. Class करना नाम ये पेन ना नहीं करना पड़ेगा. Anyone? Spare pen? No one is having. Boys, you know take control. All those things also you have to bring on the stop. Pass it. Right. 1,000 cars pass through the junction. Full stop. What is the probability that 2 or more accidents? What is the probability that 2 or more accidents occur during this period? What is the probability that 2 or more accidents occur during this period? What is given? At a busy traffic schedule, what is the chance of an individual to get an accident? 0.001. Okay. How many cars are passing through the junction? 1,000 cars. So what is the end value? 1,000. Okay. So what is supposed to find? 2 or more accidents happen on that particular day. Okay. What is the first step? You have to decide random variable. So which will fix for the random variable? What you are going to discuss? Number of accidents. So XP the random variable denoting the number of accidents. So start the solution. Let XP the random variable. Let XP the random variable denoting the number of accidents. Let X be the random variable denoting the number of accidents. Now identify the given data. What are the data given? N value is equal to 1,000. So write N is equal to 1,000. So what is it? X you assume number of accidents. So small p will be equal to the probability of an accident. What is the chance of an accident? 0.001. So that will be our p value. So write small p equal to 0.001. Now tell me, by which one you can solve? By So as I told you, whatever problems we are going to discuss can be solved both by binomial as well as Poisson. Okay, you must know the difference only. Okay, those things will be applied when you go for the higher level of the problems. When we use for the binomial, when you go for the Poisson. Okay, here in your class levels, you can solve the problems whichever I give either by binomial or by Poisson. The distribution is not mentioned. Okay, just for practice, you are going to solve it by Poisson. Okay, Poisson means what are the things you should know? How we define Poisson? E power minus lambda, lambda power x by x factorial. To solve the problem by Poisson, you need a lambda value. Where a lambda is given in the statement, then how can you find lambda? Lambda is equal to NP. I gave you that formula now. So using that one, you can find what is your lambda value. Then you can try to solve it by using our Poisson distribution. Okay, so right, lambda is equal to NP. Find what is the answer. N is 1000, 0. Others, lambda equal to NP. N is 1000 and P value is 0.001. 0.1. Yes. Now we got everything. What is supposed to find? Chance of 2 or more accidents. So what you have to find? Probability of X indicates the number of accidents. 2 or more. So what is the symbol? More. Greater than or lesser than? Greater than. 2 or more. 2 would have adhigamar. So what is the symbol will be using? Greater than or equal to 2. This is what you are supposed to find. Greater than or equal to 2 means how many values are possible? 0 or 2. 2, 3, 4, etc. We don't know how many individuals are going to get the accidents. Okay, so what is the easiest way of solving this one? Complementary. What is the complementary? 1 minus probability of x less than 2. Okay, complementary means just the opposite. So x less than 2, what are the possible values? 0 and 1. Why 0, ma'am? Whether 0 will be inclusive? X equal to 0 means what is the meaning? No accident at all. That is also possible. So 0 is inclusive. So substitute. So 1 minus. So what is the definition? E power minus lambda, lambda power x by x factorial. Poisson distribution. Substitute 1 by 1 x value. In the first case x equal to 0. So e power minus 0.1. 0.1 the whole power 0 by 0 factorial plus e power minus 0.1 the whole power 1 by 1 factorial. Find the answer. Make use of a calculator. In a calculator, exponential term will be there. So in both the terms, what is common, ma'am?
E power
minus 0.1 is common. So this can be written as 1 minus e power minus 0.1 into. Anything to the power of 0? 1. 0 factorial? 1. So this term will become 1. So this term we have taken outside. So what is 1 factorial? What is 1 factorial? 1. So you take this term to be 0.1. So 1 plus 0.1. What is 1 plus 0.1? 1.1. This is the term you have to find. Those are writing the names, write it silently now. The last three. Write it silently. The calculator e power x symbol will be there. You know where it is. Make use of that one. No calculator also. No pen, no calculator. You should not decide your loading time. How much? Which one is 4 point? This answer. What is the range of probability value? What is the range of probability value? 1, 0 to 1. How can you get the answer as 4 point? How is that possible? have made some mistakes. Do the calculation properly. Yes. Answer, ma. How come a 4 point? You're having a calculator, right? Okay. Into 10 power of the, then you should not convert that amount. Simply we are saying 4.4 point into 10 power, you are getting 1 power, no? You have to convert that, no? Shift ENG. If you get the power term is press shift and then ENG button, it will get converted to the numbers. Press that shift, then ENG symbol. Then ENG symbol. Repeatedly press that part. Shift and ENG. Till you get it as a decimal. 0.0046. How can you give an answer like that, ma? You have the 10 power term, no? So in your calculator, if you get it as the 10 power, to convert it as a number, press shift ENG. Till you get it to your decimal number, you can press that one. So what is the answer? 467. So right. 0.0047. Approximately 4 decimal places. 0.0047. Take the next one. If x is here, Poisson variate. If x is here, Poisson variate with probability of x equal to 2 is equal to 9 into probability of x equal to 4 plus 90 into probability of x equal to 6. You are given a relation. Find the mean and variance. Find the mean and variance. So in the statement it is mentioned as what distribution? Poisson. So you are going to solve this one using only our Poisson. Or given any n value, or given p value, or given lambda value. No, nothing is given. Just you are given a relation connecting the corresponding probability values. What are you supposed to find?
Mean and
variance. So what is the mean and variance for Poisson distribution? Lambda. Lambda is nothing but our parameter. So if you solve this one and find what is the lambda, that is enough. Because lambda is the same mean as well as the variance. So start the solution. For Poisson distribution, mean equal to variance is equal to lambda. Mean equal to variance is equal to lambda. So right, we know that probability of x equal to x is equal to, write your definition of Poisson, e power minus lambda power x by x factorial. Because for each probability you are going to apply the definition. Now write next line, write the given condition. Given probability of x equal to 2, probability of x equal to 2 is equal to 9 into probability of x equal to 4 plus 90 into probability of x equal to 6. Now for each one replace it by the definition. In the first case, what is the x value? 2. So e power minus lambda square by 2 factorial. That is equal to 9 into. In this case, x is equal to 4. So e power minus lambda power 4 plus 90 into x is equal to 6. E power minus lambda power 6 by 6 factorial. Okay, now we have to simplify this one and define what is a lambda. That is the objective. So leave the left hand side as it is. Right hand side, what is common in both? E power minus 1. Anything else is common? Lambda power 4 is also common. But left hand side, what you are having? Lambda square. So I will take only lambda square outside. So if you take lambda square outside, the remaining will be 9 lambda square by, what is 4 factorial? 1 into 2 into 3 into 4. 24. Plus 90 into lambda power 4 by, what is 6 factorial? 70? 720. And writing like this mark just for you to cancel and easily to identify the number. Okay, can you cancel 9 and 24? Which tables you can use? 3 tables. How many times of 3 is 9?
3.
24. 8. Can you cancel any further? No, leave it as it is. Now you can cancel this 3 with 90 to be 30 times. So what is 6 into 5? 30. Whether this can be cancelled or not? Yes, if you don't know cancellation is, as I told you, retain it as a bigger number, make use of a calculator and have it as decimal as well. Your choice. So what can do here? Lambda square and lambda square can be cancelled. Left hand side and right hand side. Similarly, e power minus lambda can also be cancelled. So what is remaining in the left hand side? 1 by 2 factorial. 2 factorial is 2. So 1 by 2 equal to 3 by 8 lambda square plus lambda power 4 by 8. 2 and 4 will be existing. Now try to rewrite this as an equation in terms of a lambda. So both is having common denominator among. Bring it to the left hand side. What you will get? 8 will come here. What is 8 by 2? 4. So you will get this to be 4 equal to lambda square plus lambda power 4. That is, we can rewrite this as lambda power
3
plus 3 lambda square minus 4 equal to 0. Okay, we have written this as an equation in terms of lambda. Can you understand how to simplify? Simplify is better because if you cannot everything to decimal means finding out will be a difficult one in some problems. If it becomes as a whole number means no issues. If it is a decimal means finding the root will be difficult. But you are having calculator, but what is the drawback in a calculator is that it will not show your imaginary roots. Then you may miss your values. So what type of equation is this one? What degree? 4. Okay, so about how many values of lambda you have to find? 4. Quadratic equation means 2 roots. This is an equation of degree 4. So you have to find 4 different values for lambda. It may be same also, but you have to find 4 values. How can we solve it? Yes, very good. Everyone knows how to solve for the quadratic equation. So try to convert this as a quadratic equation. Just for convenience, assume x is equal to lambda square. So what happened to lambda power 4?
X square.
X square. So x square plus 3x minus 4 equal to 0. Now it is a quadratic one. You can find it for x. From x you can find what is for lambda. What are the roots for this one now? If you multiply means you will get it as minus 4. If you add means you must get it as 3. So what are the two numbers you can use? 4 and minus 1. Now, no yosike venda, you have a calculator. Okay, you solve the quadratic equation here, calculator. Substitute in that one and find what is the roots. Okay, so x square plus 4x minus 4 equal to 0. This 3x is written as 4x minus x. What is common in the first two terms? X. So take it outside. X plus 4. In this 2, minus 1 is common, so x plus 4. So you get your x values to be minus 4 and 1. X plus 4 into x minus 1. So you get your x Okay, this is only x now. What are you supposed to find? Lambda. So what is x?
Lambda square.
Lambda square. So this is the answer for lambda square. From that lambda square, we will find what is the answer for lambda. So that is you get lambda square is equal to minus 4 or lambda square is equal to 1. Tell me what are the lambda values?
Plus or minus 2y.
Lambda equal to plus or minus
2y.
2y. Because you are getting minus 4. Square root of 4 is 2. But square root of minus 1 will be 1. What is lambda square equal to 1? So what is lambda? Plus or minus 1. Whenever you take square root, you will be having a plus or minus 1. So how many values are there for lambda? 4 values. Which is the correct value for lambda?
Plus or minus 1.
Plus or minus
Plus.
Whether it can be imaginary value?
No.
Whether it can be a negative value? No. So what is the only possibility? 1. So right? Lambda cannot be imaginary value. Lambda cannot be imaginary value or negative. Therefore, lambda equal to 1. So what is your actual question mark?
Find
Mean and variance. So write the conclusion. What is the mean and what is the variance? 1. Both are equal to 1. So right? Hence, mean equal to variance is equal to 1. Mean equal to variance is equal to 1. So repeatedly I am telling you, even if you listen also you will understand only 50%. If you are not listening at all, you will be at 0 level only. No one can help you in that. Have you understood this problem now? Any doubts? Yes? Okay. Next one. We'll solve one more problem, then we'll go for the next distribution. Now, today we have one more hour also. Third hour. So by that, I think we can complete the discrete distributions. We can start with the continuous one. So take the next problem. It is known that the probability of an item produced by a certain machine will be defective is 0.05 if the produced items are sent to the market in packets of 20 comma find the number of packets containing at least comma at most and exactly two defective items in a consignment of 1000 packets. Okay, so read the question. Understand what is given? What is given?
Machine produces
The machine produces
items
items. Okay then.
0.05 is defective.
What is the chance of getting a defective item? 0.05. It is corresponds to which value? Say it louder. P. The chance of getting a defective item is, it indicates the probability value. So what is the probability of a defective item? 0.05. So given P value equal to 0.05. What is the next one given? The items produced are sent to the market in packets of 20. Okay. So find the number of packets containing, some categories are given, in a consignment of 1000 packets. So consignment la evlo packets irukku? 1000. In each one there will be a 20. Okay, wow. So what are the assumptions you will make now? You have two values now, 20 and 1000. What is those? Overall consignment is having 1000. So that will be indicating which value? Capital overall. But each one is going to have 20. So that will indicate small n. Over paid billion 20 irukku podu. So that will indicate small n. ஒட்டுமொத்தமா எவ்வளவு packets இருக்க போகுது? 1000. So that will be indicating the capital N. Okay, so start the solution. Given small n equal to 20, capital N is equal to 1000. Small n equal to 20, capital N is equal to 1000. Now tell me what you are supposed to find now. See the question.
Number of packets contains at least
At most exactly
two defective.
two defective items. So you are going to find the probability for defective item or good item?
Defective.
So for that one only you have introduced a random variable x. Okay, wow. So whatever you are supposed to find, to that one only you are going to introduce a random variable. Okay, so right. Let x be the random variable. Let x be the random variable denoting the number of defective items. Denoting the number of defective items. Now corresponding to x only and fix your p value. X indicates for defective. So what will be p? Now what is the form of statement? X indicates the number of defective items. So what should be p? Statement. Probability of defective item or good item? Defective. X எதுக்கு fix பண்றீங்களோ அதே தான் எதுக்கு fix பண்ணணும், p க்கும் fix பண்ணணும். Because x is the number of success, p is the probability of success. So right, small p equal to probability of defective. Small p equal to probability of defective. What it is given, ma? 0.05. Now tell me, which distribution you want to solve? Binomial or Poisson? Binomial. You can solve both by binomial as well as by Poisson. Binomial means what will be the formula? NCX, P power x, Q power n minus x. If it is Poisson, equal minus lambda power x by x square. That is the only the difference. You are going to replace it by some other formula, but all the others will be the same. So Poisson means you need lambda value. Okay, we'll stop. We'll continue our third. Can go for class, ma.